Hello and welcome. This week I want to talk about tube maintenance, or actually tube inspection defects. I'm calling this everything you want to know about tubes but we're afraid to ask. And we're going to do a real quick thing of how to take a look at when you're inspecting airplanes and looking at the tubing. I work at a repair station that's a 145 repair station that does aircraft tubing, and so we see a lot of tubing. And I don't want to give you a big commercial or anything like that, but what I will say is here's what you're looking for in the field. Right here we see a picture where a tube has broken, and it's broken right at the end of a bend. Now when you bend a tube, you work hardened it, and that's part of the bending process. And so that work hardened area is what forms the bend. That's what keeps it in location. But then the straight sections are soft. So oftentimes we see a break right next to a bend. Usually that's a fatigue type issue. Now maybe somebody forgot to disconnect a fitting, and when they pulled a component off the airplane, they might have broken it right at the bend, and that's pretty common. But the other thing that we see is if you have a tube that's not properly supported with Adel clamps or support, this thing will sit in flight and vibrate, and that will be a fatigue issue, and fatigue will cause a crack and a break. This particular line is aluminum, and some of the aluminums, heat-treated aluminums like 6061 T6, these things can actually be pretty brittle, and it's like a potato chip. You know, you try to bend a potato chip back and forth and it breaks. So this is one type of defect we see. This is a stress riser at the end of a bend that resulted in a breakage of a tube. This defect here is not quite as easy to find. This is a anodized fitting. The tube is alodined, the fitting is anodized. And what we see on this gold color is we see pitting. Now this tube is history. These pits go so deep, you're deeper than 10% of the material thickness of this nut. And we also see this on all kinds of aluminum anodized fittings. We see this pitting corrosion. Usually happens somewhere after about 30 years to 40 years of aircraft life. Pinholes. Pinholes are very common things in tubes. Where you usually find a pinhole is in the outside area of a bend. When you do a bend, the inside is compressed, the outside part is stretched. So the outside diameter has a further area to travel. The material is thinner, and so this thinner material, that's where it'll fail first. And what we see here is we see pinholes right in the outside of the bend. Some people call this the heel of the bend. And so if you're looking for a hydraulic leak on an airplane, you pressurize it up, you look at it, take a good look, especially at a big bend like a 90-degree bend or a bigger bend, and you might find a pinhole. Look for that fan of hydraulic fluid, or that fan of oil, or oil laying down in the bottom of the airplane right above it. Here's a chafe. The tube has been rubbing against something else. This is aluminum, so aluminum is pretty fragile. Usually with chafes, most manufacturers only allow 10% of the wall thickness to be damaged. So if you have a tube that's like a ½ inch with an 35 thousandths wall, 10% is 3½ thousandths. 5%, some damage things, you have to look it up in your maintenance manual, chapter 20 in most aircraft maintenance manuals, and it might not even be there. 10%, you can also look at the 4313. 10%, you absolutely can't go past 10% with most tubes, and 5% if it's something high pressure or critical. Now tubes rubbing together, you know, if you've got two lines that are real close to each other, that's where you really need to inspect for chafing. If you find it quick enough and you can keep it from chafing, you can put a piece of rubber hose around it, tie wrap it, anything to keep those two metal to metal parts from contacting each other. Here's some damage. This was mechanic damage. This is where somebody got into it with a wrench. The gouge is sharp and V-bottomed. That's a no-go. That's a failed tube right there. There's nothing that can be done to save this particular tube. This is more foreign object damage here. This is a sharp V-bottomed dent. A gentle dent, sometimes we can live with. You can find damage limitations on that, 4313 or your manufacturer's manual. But this has a sharp edge to it, and that's a stress riser, and that right there is cause for rejection. This is a Wiggins fitting, and this is a fuel system line, a weird line on there. This goes to a vent where you can see there's corrosion damage at the end of the hat of the tube here. This is, I call it a top hat. This is what a tube failure looks like. This was a blowout. This is where the tube failed. There's probably a scratch or a nick on the outside, and this thing got enough pressure that it found a thin spot and blew out. This is a brazed fitting. The manufacturer, Douglas Aircraft, brazed this, and this is an illegal field repair. Someone went and welded on the tube. You never ever field weld on a tube. You cannot use an acetylene torch to do a tube repair. You're not allowed to braze a hydraulic line, okay? If it's a drain line or something like that, different story, but this is a hydraulic line and you can't mess around with pressure hydraulic lines. I hope this was of help to you. Our inspection authorization program at repairstationtraining.com has a whole section on hydraulic tubing and repairs. It talks about a lot of the things that you saw in this section. Thanks for tuning in, and don't forget you can find us on Twitter. We're at RunUpArea. Thanks for watching.